Hi. This here is the second part of the previous video I have done about the inside quantum magnet field shown by the Ferrolens in 2D and how this translates in an actual 3D space field. I've done this second part because my collaborator Wolfgang Daimler, which is a theoretical physicist and an excellent animator, did some additional animation, and I'd like now to share this with you. So we have seen in the previous video that the actual field is in 3D space of an electron. In an extension, it's still version for any magnetic ferromagnetic dipole, is this field here, and we see here how the lines are communing through the horn torus, here, and looping between the two poles, spiraling and looping between the two poles. And we said also that if you look this model from top view, this is the North Pole now, and this is the South Pole. The lines are spiraling out and spiraling in to the South Pole. So this is actually what is displayed side by side by the lens, and we can see also the spiraling lines from the bottom pole, from the South Pole, which are here look more fade, and the more contrast blue lines are the lines, the spirals on the top of the magnet, which is the North Pole. And as I have said before, we can see that's very prominent also in the Ferrolens. If it's quite sensitive, then we see here the lines also, this effect with the lines here from the one pole, the spirals overlapping with the lines, the more fade lines on the bottom pole, which is the South Pole. And also here you can see this effect. Okay, and we said in the previous video that these bright dots here are not lines which are colliding with each other. They're just or crisscrossing. They are only overlapping in 3D space, and because the thin film of the Ferrolens is very, very thin, 25 to 50 microns, because they are very, very close together here at this point, one above the other, the scattering effect is more strong, and therefore get these brighter dots in each intersection point here. But as we said before, they're not crisscrossing, they're not touching each other, they're just overlapping in 3D space, as shown in this animation here. They're overlapping in 3D space. They're coming here all the way, going back of the sphere, and then eventually spiraling in. So there's a distance here. They're overlapping, they're not touching each other. And yes, Wolfgang did an excellent animation now, how this translates what we see on the Ferrolens, and he actually animated this as well. So we have the lines here from the North Pole, yes, and here is the polar field view as we see it in the Ferrolens from the South Pole. And we'll see also the fader lines here at the bottom. I have told in many videos before this that the Ferrolens has a see-through property. When you look through from above one pole, you can see the lines, the spirals from the other pole, from the opposite pole. It has a see-through property, yes, and as we can see here, and also here. So whenever you look the lines from one pole, you can see the lines also behind these fader lines coming, the spirals coming from the other pole. It's totally see-through. So this is amazing. So when we now compare this with this image, we can see here also again this crisscrossing, which are actually the lines from the other pole. So this now these two holes there are in a U-shaped connection actually inside, but in the Ferrolens we cannot see the connection. We cannot see this connection here. It's broken now. When we project the field from 3D to 2D, the horn torus tube which connects the two poles is broken. So this here, this horn torus is now broken. We cannot see that in a 2D projection. So that gives us this image here, and we see here here in the joint section, because there is more pressures, the lines are losing the curl when displayed by the Ferrolens and becoming straight. They're straightened up. So this is actually what we refer as as domain wall region on the Ferrocell, on the Ferrolens. Yes, these lines are, because they are the two poles now, the two vortices are coming together. There is pressure here inside. The flux lines here are pressurized, and therefore they're appearing without curl and straight. So yes, and so yes, as I have written here, each line loops between the two poles passing through the horn torus tube in 3D space, and therefore the lines never collide with each other. However, in 2D flat space, this is not possible to be done without the lines colliding with each other, and thus the Ferrolens cannot display this in 2D. As a physical device, it has to obey physical rules. The double horn torus connection is broken in 2D space. And I believe that we really have deciphered the Ferrolens display of the quantum magnet field here. So this is actually my interpretation of what is happening, and I believe this explanation is very important, how this 3D field is then cut here, split, and displayed as a 2D image, with the lines here of the two joined here vortices coming close together, and the pressure here which is existing inside the physical lens. I tell you that it's there is matter in there in the form of magnetic nanochains, which are layering and coming together very close, and there is also a pressure inside the fluid where they are floating in, and all this makes here the lines straighten up. And this here we say it's the domain wall. Okay, of these two. And again, as I have told you before, the lines here, whenever we look inside the Ferrolens, even when we have it in the side view with a magnet placed on its side on the Ferrolens, we can see on each pole the lines mirrored from the other pole. So we see here, these are the lines from this pole, but we can see also the spirals coming from the other pole, because the see-through property, I repeat, of the Ferrolens. Yes? So when you look here, you see also the lines of this here are mirrored here, and also vice versa. The lines, we can see the lines, the spirals from this pole, but also the mirrored lines coming from the other pole. It's a total see-through property of the lens. And the lines, the two vortices, when joined together here, the pressure straighten up the two vortices, and the lines now appear flat and straight. But what is really happening, because we cannot, because the connection here in 2D space cannot be displayed, we see this final interpretation of the quantum field of the magnet on the Ferrolens, as shown here on the animation of the excellent animation of Tollner, which I have linked his site in this video. Okay, so that's it. That's all. Again, thank you very much for listening. This is Emmanouil Markoulakis from the Hellenic Mediterranean University. Thank you and goodbye, and keep safe and healthy. Bye.